What's good, YouTube? Back at it again with another video. I'm Bruce from Jump Mathematics. In this video, we will be discussing more examples on how we can apply the product rule in order to compute derivatives. Let's go ahead and get started. So what we want to do is we want to identify which function is going to be our f and which function is going to be our g. I'm going to call this one f and this one g. If we know what f and g are, then we can compute f prime and g prime, which are both required. F prime, we've calculated the derivative of functions like this before. 1 over 2 root t plus 2t. And g prime, we saw to be the derivative of e to the t is, again, e to the t. So then what we're going to do is, now that we have f prime and g prime, which are each of the four functions required, we're just going to go ahead and plug those in here. F prime is 1 over 2 root t plus 2t times g, e to the t, plus f is root t plus t squared, again times g prime is e to the t. And then just because both of these factors have an e to the t, you don't have to, but I'm going to pull them out anyways. E to the t times 1 over 2 root t plus root t plus 2t plus t squared. This is the derivative of this function. Very complicated function, pretty complicated derivative. But we see that if we identify fg, we write down f prime and g prime, all we have to do is plug each of those four functions into this formula. Let's move on to this one. So one way that we could attack this problem is by foiling out s squared plus 1 times s squared plus 1. We'd get a quartic function, s to the fourth. That's not gonna, that is one way that definitely could work, and you could use that as a way to check your answer. But in order to leverage the product rule, what we're going to do today is rewrite this as, of course, d by ds s squared plus 1 times s squared plus 1. Then it's obvious which function we want to use as our f and g. That's f, that's g. Since f is equal to g, f prime is equal to g prime is equal to, let's calculate it. The derivative of s squared plus 1 is 2s. Okay, now we have f and g, f prime and g prime. Let's go ahead and plug those in here. F prime g plus f g prime. This derivative is equal to f prime, 2s, times g, s squared plus 1, plus f, s squared plus 1, times g prime, 2s. This factor and this factor are the same factors, so we have 2 times 2s times s squared plus 1. Let's go ahead and distribute. This 2 times 2 gives us a 4. We have 4s times s squared plus 1. We get 4s cubed plus 4s. This is our derivative. You can pull out a 4. You can just leave it as 4s times s squared plus 1. Doesn't matter. This is our derivative. Let's go ahead and check our answer using the old school rules that we know. d by ds s squared plus 1 squared is equal to the derivative of this, is equal to the derivative of s to the fourth, that's this term times this term, plus 2 times s squared times 1, 2s squared, plus 1 times 1 is 1. So what we did was we FOILed this out and just rewrote it down here. So let's go ahead and calculate the derivative of this. We know to be equal to the derivative of this. This is just a polynomial, so we can differentiate it as 4s cubed plus 4s. Hey, look at that, it's the same. Both processes work. The first one that we did, we used the product rule in order to compute the derivative. The second one, we did the old school way where we FOILed and then just differentiated the polynomial. And not to our surprise, we got the same answer for both. Hey, what's going on, guys? Thank you for watching the video. If you're interested in getting better at math by getting all kinds of practice, what I want you to do is go to jumpmathematics.com. Here I provide you with free instructional videos and hundreds of practice problems. This is the best way to get better at math by doing practice problems. See you in the next video.